Well, thank you all for joining us today. My name is Marie Donnelly. I am a business development and licensing manager here with CTL. And I'm really excited to present to you today one of our commercialization modules as part of this Lab to Impact series, where we'll be talking with Professor Syed Rizvi from the Department of Food Science and with Aris Despo, an entrepreneur, about their journey bringing a technology out of out of the Rizvi lab and hopefully into the marketplace soon. We'd really like for this to be a conversation. So if you've got questions, please feel free to raise your hand or to drop them in the chat, and I can bring them up with our presenters during the call, and we can answer questions in real time. And so to get things started, let's go with some introductions. Syed, would you like to please introduce yourself and maybe tell us a little bit about your background in food engineering and how it's led to your current role at Cornell and this project?
Very good. Thank you, Marie. It's a pleasure to be here and take part in this very interesting conversation. My name is Syed Rizvi, and I am a professor in food process engineering in the Department of Food Science at Cornell. My background includes, I have 3 degrees. First, bachelor's degree in technology, master's degree in engineering, and PhD in science. So I have food science and engineering background, and I've been doing work mostly in that space for the last 40 years. And most of the time, I'm interested in novel processes for making products and, formulations in a very different unit operations, in a very different set of operating conditions using novel technologies to create a product that did not exist before. So my motivation is not that Me Too type of product, but a novel, a new kind of either a product or a process, or increasing the knowledge base on which some of these processes are based. So I do research in that area and also do teaching. So I've been doing that for the last 42 years at Cornell.
Great. Thank you. And Aris, why don't you tell us a little bit about your story? What's kind of led you to where we are today?
Okay. Well, first, my background is actually was physical organic chemistry. I had working on my doctorate at South Carolina, which I left early to start a specialty chemical company, manufacturing, which fortunately was able to sell to my largest competitor after 20 years. Got involved with on Wall Street, doing a turnaround of a public company and growing it and actually changing to medical device for 10 years. Then my joy was working with startups, helping them raise capital, and went in as interim CEO. And then found my way here to Cornell to CTL in 2019, which was spent 6.5 years of great enjoyment and great relationships, working with some amazing PIs. And that's how I met Syed, because I managed his portfolio, and which included the ice cream that we're talking about today. So I left Cornell to work on this last August, and here we are.
Yeah, so today we're going to talk specifically about this ice cream project and trying to bring this to market, but also more broadly about strategies and maybe hurdles, regulatory hurdles, or other hurdles getting food technologies commercialized. So again, if anybody has any questions, please feel free to drop them in the chat. So more specifically about this technology, Syed, can you talk about briefly about the technology itself, the instant ice cream? What allows you to instantly freeze the ice cream mix, and kind of what does the product look like at the end of it?
Yeah, so we've been working with supercritical fluids for some time, and it's a kind of a material which is neither liquid nor gas, has some properties of liquids and some properties of gases. So it has a very unique set of properties that can be exploited in a lot of things, especially related to food. So supercritical carbon dioxide is the one that is used for decaffeination of coffee. Instead of organic solvents, they use carbon dioxide at high pressure to decaffeinate coffee and extract some of the other materials of interest in food industry, like flavor and fragrances, oils, and that sort of thing. So our interest, was in that area as well, and we did a lot of work. Then all of a sudden we realized that when carbon dioxide goes through from high pressure to low pressure really creates a lot of strong cooling effect. And how do you take advantage of that cooling effect when you go from high pressure to low pressure? When you throttle the process from to atmospheric pressure, the temperature drops by 60, 70, 80 degrees. So I said, wow, that will be very interesting if you can use that, capture that cooling effect into doing something very unique and different in food industry. So we designed a system whereby we can take in any flowable liquid and we combine the effect, two effects. One is known as Bernoulli's effect, where we create, low pressure and products gets pulled in, and the other one is Joule-Thomson cooling effect when you go from high pressure to low pressure. We combine very unique way. This is our claim to fame, is very unique way in combining these two principles, whereby we can take a liquid, pull into a carbon dioxide stream, and it freezes instantaneously. There's no such thing as microwave freezing. There's a microwave for heating, which heats the liquid the water very quickly, but there's no such thing as freezing in such an instant process. But with this technology, we can freeze a scoop of ice cream or 150, 200 gram of water in like 2 or 3 seconds. It goes from liquid to solid. So we said, wow, what is the process? What is the product where rate of freezing is very important? As we know that rate of freezing determines the crystal size. The faster the freezing, the smaller the crystal size, the better the texture smoothness. We thought, wow, the ice cream is the one where they always try to minimize crystal growth and to keep the product smooth and not gritty. And therefore, if we can apply it to ice cream freezing, it'll be wonderful. And lo and behold, we tried that and it did exactly what was expected. It froze within 3 seconds about 150, 200 gram of ice cream. And the crystal size was so small, so smooth that it was amazing. And that's what got us started into applying this technology to freezing of ice cream, but it can be applied to freezing of any flowable liquid. Like we can freeze water, we can make carbonated ice, we can make a slushy soda, you name it, any liquid product can be partially frozen and made into slushy or solid ice. And that's what we did. We have developed this technology to do.
Yeah. So when you're developing new technologies such as this one, how are you balancing the pursuit of the scientific innovation and the discoveries with what is going to be commercial feasibility? I mean, you mentioned that the supercritical process is already used in food processing.
Mhm.
So how do you, when you're thinking of the innovations that you want to pursue and discover, how are you balancing what might be an eventual commercial application with that?
So first and foremost, we are in academic institutions. So our focus is always discovery of new knowledge. So that's number one fundamental thing is how we can do things differently, what this means, what is the science behind it, how do you capitalize on it? And then once we understand that, then we start looking for where can we apply this? So when we see that two scientific principles can be combined into one, and that's a very unique thing. Nobody else had done that before. And when we combined them and it became a process, then we started looking for applications. Is there an application that this will be really ideal technology to apply to? And it turns out that liquid foods is a good place to be. And that's what we started doing. But we have done a lot of basic fundamental work on designing the different types of nozzles and design the different types of inductors where they come together. So it's a little bit more complicated, scientifically very challenging. But the bottom line is it makes a product that's unique and different and something that does not exist.
Great, thank you. So Aris, you mentioned that you had previously worked for CTL and you met Syed during that. And so you were part of the evaluating this technology for its commercial applications and trying to find a development path for it. So can you talk a little bit about, when you were in your previous roles, when you were looking at a technology, what are you looking for to evaluate its commercial potential and what kind of caught your eye with this technology?
Sure. Probably the first thing, probably most important is, what pain does it cure? What is its solution for that pain for a particular customer? So, part of our search of the technology was in discussion with say it was, first of all, to understand, to get an understanding of, how it works and what are the applications. Number two, then, is to really look into the market. Okay, and the market for this is so broad, and where can you take it? The second real important item was, is it scalable, right? Is the cost to scale, viable? Because you can have a great technology, but it's too costly to bring it to market. The third item is IP. There is an issued US patent. There are several design patents, and there's an existing PCT. So you want to create that, IP moat, because you want the exclusivity for a period of time to be able to build the market, create the brand. And then the last item was, of course, the bottom line is, the cost is the final part, of the final product. In this particular case, we have a couple of different, avenues for it. We have targeted coffee shops first, which we consider low-hanging fruit. You have independents, and you have chain. Here in the U.S., you have a combination of both, upwards to over 91,000. Okay. So the numbers are there. And if you take this and look at Europe, and they're close to 150, about 70,000 coffee shops. Asia has over 200,000. So the numbers say, hey, I'm worth looking at. Along the journey, we also, while at CTL, is probably interviewed close to 100 potential users, most of them on the independent side. And they just talked really about their pain point was, hey, I really want to bring another product in, to create another stream of happy customers. And we talked about ice cream. Of course, their concern was, hey, I don't want to be a ice cream parlor. I don't want to be scooping. And I'm limited by space. So those are criteria that we look at, and how do we manage that? So this fit all those. Also along the way, I did take the certificate class in startups and fundraising, and I used this Syed's technology as my project. And that's when I really dug in. I said, I caught the bug.
Well, that's great. I mean, we talked about where the applications are going to be, and you've mentioned coffee shops. How did you really zero in on identifying coffee shops or these other kind of small eateries as your target customer instead of these companies that are just trying to maybe bring in a new product? Talk a little bit about the process of getting there.
Yeah, I mean, that came from just, customer discovery, which is critical. And that's where over 100 interviews, looking at the market, we automatically decided we did not want to compete with ice cream parlors. We have no intentions of having a palette of flavors. Just like going into a restaurant, you'll have 1, 2, maybe 3 flavors. We want to focus on doing something very well. A second area of interest came to us through a conversation with a master chef, in which we had no idea that there were only about 70 master chefs in the world, and they're also associated with many of the high culinary places. And they have an interest for the Michelin restaurants that enable the Michelin restaurants, their chefs, to make their specialty ice cream for that day. And time is of the essence for them. And so, which Syed will probably tell more about, that for these culinary experiences, when a chef makes an ice cream, it will take upwards to a day and a half for it to really freeze properly. Versus here you have the ability to make a scoop of ice cream, 1 or 2, 1 scoop in less than 5 seconds, and then you make a second scoop. So it's really very, the simplicity of this really caught their eye. So we're going actually on two tracks, but our primary track is public shops because of the pure numbers. Yeah.
Right. I think a good question maybe to think about for both of you is that, oftentimes, at the university, we find technologies work really well at the bench. They work really well at the lab scale. But obviously for commercialization purposes, we need something to work at a larger scale. So what are kind of some of the key considerations that you want to see or that you want to consider when you're thinking about the transition from a technology at the bench to more of a production scale or pilot scale?
I'll start that one side and jump in. I think the first thing is process control. Being able to make something reliable. That's number one, one and two. Is it serviceable? Because you don't want something that's so complicated that it's always breaking down. And the final one, of course, which many on the CapEx would be cost. Is it viably cost effective? And I think that kind of summarizes.
Are these some of the things that you're considering when you're designing the processes and products there, Syed?
Yeah, I mean, the technology is really not that complicated. It's two technologies put together, and if you want me to, I can share a little video. So here is a cryogenic freezing. One scoop in 3 seconds. You can see here is the ice cream mix. Put in the machine, simple, and you put a cup to collect this. Here you go. Here's a scoop of ice cream, and you see it's a hard ice cream. It's not soft serve. It's at -9 degrees. It's a
Yeah, I
hard
think
ice
that's
cream.
one of the really unique things about this technology is we've seen other like very quick and other instant ice cream technology, but they're a soft serve, which is it's a fine product on its own. But hard scoop really is the I think what people are looking for when they're looking for ice cream. This
Yeah,
is really
and you can
exciting.
see we have done a number of products. We can make ice, we can make sorbet, frozen milk, ice cream, a number of different products, and they're all very clean label because you make it instantly and you consume it. There's no need to put anything to preserve the quality. And if you see this, what I call it, functionalized ice. See, if you take the same system and put water in the cup instead of ice cream mix, and here you get carbonated ice in 3 seconds again. And this is the frozen ice. Now look at the properties of this ice. You take this ice, put it on there, it looks like regular ice, but it's a little bit different. So you take this and you squeeze it, and it's a squeezable ice. It's a carbonated ice with a lot of water that's cold water and trapped in there along with ice. So it's a very unique and different way of making carbonated drink, where you can take this ice, which is carbonated, put in water, and you get carbonated, soda water, basically, because it has carbon dioxide in it. So you can see we have done it different ways, and you can see water in the ice, 25, 30% water, it stays as liquid, and rest is frozen. So there are a number of uses for this technology. So you can see now the technology is very adaptable. You can really share it in terms of scaling it up and making a larger scale system not too difficult to do that. It's not very challenging. It has its own challenges in terms of cleanability and sustainability and all that sort of issues, but it's very doable in my opinion, at least.
We've had a question actually come in. They want to know how can you control overrun, especially the air bubble size using the technology in the 2 to 3 seconds? And then how are
Right.
the ice crystals going to behave during temperature use?
Right. So first thing is overrun is kind of low compared to conventional ice cream. In ice cream domain, there are really good quality Haagen-Dazs type, more high-end ice creams that have lower overrun. and then there's cheaper version which have very high overrun. So our ice cream fits into the lower overrun categories, like 25, 30% overrun. We don't get 100%. And number two is the quality is very, very superior because two things. One is crystal size is very small, and then you get little carbonation in the ice cream, which gives you very, very unique and different taste that people have tried to incorporate in normal ice cream instead of air, whipping carbon dioxide into it to get carbonated ice cream. But here we get a little bit of that because of carbon dioxide being entrapped in the ice cream.
Yeah, let me add in on that. I mean, the smaller crystals and we're calling it, CO2 infused ice cream on is extremely, creamy and very robust. We've had quite a few independent people who have come visit the lab and taste it, and they walked away, amazed by it. I mean, that's what captured my interest, and I'm an ice cream fiend, you know.
Yeah.
And also,
And I think the other understanding is that it's on demand. It's not, our initial market being whether it's coffee shops or other quick service facilities is for on demand at that time. It's not for pack and go.
so you're doing, you're literally getting rid of the cold chain. You don't need minus 20-degree cold chain to make it in Buffalo and sell it in New York City. You make it where it's needed and consume it, and you're done. The important thing also in this process is our quality is, freezing is so quick that you take normally concentrated milk. If you just take concentrated milk, put some sugar in it, and put it through the system, it gives you very smooth, concentrated, sweet tasting milk that you've never tasted before. Just taking pure milk and putting a little bit sugar and flavor if necessary, and you get very unique, different product. So there are very many possible options in terms of creating new products as well, besides just ice cream.
Oh, that's great. And for full disclosure, I've gotten to taste this ice cream as well, and it is really good, really cool, very creamy. So kind of leaning into a little bit more of this commercialization aspect of it. So Aris, in your past at CTL, one of the things that we're always thinking about when we're evaluating a technology is what is going to be the best commercialization path for this? Is it going to be licensing it to an existing company? Can we find a partner to develop it? Or should we be looking to support a startup? So Aris, when you were thinking about technology, what would you look for in one where it was going to be maybe a technology that would be best for partnering, or versus what are the features of a potentially startupable technology that you were looking for?
Yeah, I think in a traditional sense of if you want to put something in a particular column, the focus on startups because the technology still needs more development, and versus licensing it to let's say a Carpugini over in Italy, who makes a lot of machines for ice cream and gelato. It's not there. I've chatted with them as under CTL, and they just wanted a little more development. It just made sense in this case, as in many of the other early technologies out of Cornell, is the de-risking phase. Come up with a design, you test it, you create some traction with customers, you create that pool in the marketplace. So I think that's the differentiation. If you'd also remember, we did originally license this technology to a group out of Silicon Valley. But unfortunately, they weren't able to meet milestones because of personal issues.
Mm-hmm.
And we had to take it back. And fortunately, I'm glad we did. No, because this opportunity wouldn't be here.
Yeah, so kind of building on that, what really inspired you, Aris, to pick this up and create a startup around this?
Well, I've done lean startups before. Yeah. And this one just resonated with me. One, I'm a big fan of coffee shops. I mean, when I worked on my executive MBA, I did it at a Starbucks. You know, because you had the kids at home and you needed some quiet, and you wouldn't think that Starbucks was quiet, all right? But it was quieter than a couple of boys running around. You know. So and then conversations with owners of these independent shops, and they all talked about they want to increase their margins. They want to bring in another set of foot traffic. And this kind of fit the bill. As more and I dug into it and reached out to groups and talked to them, everything started to make sense. Syed, I've worked on separately a new design for the device, and that would be great in coffee shops. Fits for a barista. We're talking about it being experiential because you have the noise from the CO2, and you associate that. Hey, this is freshness. It's just being made. So these type of experiences, and it checked all my boxes.
That's great. How about you, Syed? What has your experience been as a faculty member, kind of from the faculty side, working with founders and working on startups, maybe working specifically with Aris on this project?
Well, we have a number of technologies that we have worked with the industry and other people before. And it's very unique. It depends on the combination of the right combination to really take it forward. Sometimes you don't foresee some of the hurdles that come on the way when you're moving forward. So as an academic person, I'm not very in tune with what are some of the commercial requirements, but that's where people like Aris, and others become very useful and guide us in the right way. And we have, other technologies that are currently being evaluated and practiced. So some of them are more successful than others, as you'll expect. But the bottom line is that we have to do things in a translational research that we take our ideas and try to put into the marketplace. And that's what we need partners like Aris.
And you've
So
worked with
there
some,
are other applications here besides for ice cream.
right.
Not only
Yeah.
what Syed spoke of. Some of them probably require more on the regulatory side. And that was also the reason why for going this route, because the regulatory was very minimal on this. Whereas had discussions with some IVF facilities for instant freezing of eggs. And so that's something that we're exploring. But that's something down the road. Some other biological fluids.
But there's more regulatory hurdles there?
Absolutely.
Yeah. Do you want to talk a little bit about the regulatory path that you are thinking, if you're going to encounter for the food product, and then maybe kind of what are your considerations as an entrepreneur when you're going to have to, deal with a regulatory agency?
Yeah. So right now, because our source of the ice cream mix, and we're going to be using UHT, ultra high temperature process, which gives us a long shelf life under ambient conditions. And we don't have anything extra there. We will pick out the packaging that will go with our device. That will be filled by a third party. As far as the operation of the system, we're looking at industry certification. There's nothing that we have to do with the US FDA or USDA on this particular technology. But we'll look at some certification, UL certification, NSF, because some of the chains will require that. Locally, in each state, we're going to have to register, with the health department. So there are steps that we have to take along the way, but they're not barriers. They're easily overcome.
I think that's a good thing for entrepreneurs to keep in mind as they're developing these new technologies. So kind of thinking broadly about entrepreneurship, What are some of the first steps that a startup founder should take when they're thinking about spinning out a technology from Cornell? And how should they involve the collaborating faculty member?
Well, definitely it's critical. I mean, you need to understand the technology, because no one knows more than the PI and the PhD student or the postdoc. You want to engage them. In this particular case, Syed is a scientific advisor to Flash Innovations. We have intentions to, for example, one of the postdocs who has gone back to Bangladesh, that will engage in him, because there's a learning curve there. We don't want to hire someone who doesn't have a learning already. So from my standpoint, time to development is very critical. And if you have people who already have those skills, and they have to be, picked up separately by a new candidate, that's critical. Number two is building processes internally that enable you to delegate internally as an entrepreneur. One person can't do it. And so I think those are the two main things. There's a whole list of them that I can always point out, but I think those are the two main things.
Makes sense. So,
probably the last one that was funding. You can't do anything without funding.
yeah, that's very true. Yeah, always have to be looking for the next funding round, I guess. As soon as you close one round, you're starting the next.
Right.
I think we talked briefly about a patent moat. How critical do you think that intellectual property protection is in food science and in food technology spaces? And Syed, I know you've got involvement in several other companies, so maybe you want to touch on this as well. What is the value of the intellectual property protection for these companies?
I think patent is very important for companies to invest in a technology that they know that they own it for some time at least. Without that protection, it's kind of a trade secret or something that they can operate on, but we don't. We are a university system, so we have to register our intellectual property and get a patent if possible. Sometimes it takes longer than necessary, to get a patent, but it is very helpful once you get it, because then companies have confidence in the technology that they can benefit from it for some time. So we do go for IP, and CTL helps us, as you know, you are part of it. That we won't be able to do it unless it was the help you guys provide in licensing the technology and also finding the users that come through your office to us and look into the technologies.
Yeah, Aris, as you're out there talking to potential investors, is this something that comes up as well, that they see the value in the intellectual property protection?
Oh, absolutely. It's about reducing risk. And IP enables you to create that moat. But the IP has to be defensible, right? You can have a lot of IP out there, but it doesn't mean anything if it's not defensible. Now, in this particular case, we look for, on the equipment side, recipes, just like a Coke formula, it can be kept as a trade secret, right? But on the equipment side, you want the IP for a company that you're able to defend in your market. You're going to be able to capture that market, and the IP enables you to do that. Investors like it because that's what box they check, that reduces their risk profile.
What are some of the infrastructure or the resources that are really critical for a startup, for an early stage food tech startup? And are there, what is the availability of those resources at Cornell?
Yeah, so Cornell is a great place for that. When I started my first company in South Carolina, none of that stuff was available. You didn't have labs that you can go further development. You didn't have access to mentors on the business side, and that's absolutely critical. I'm just finishing up doing some mentoring over at the College of Engineering for entrepreneurship and commercialization. And having that background, and they're doing these projects, and I wish I had that because it would have shortened my timeline on execution. Because this knowledge enables you to to identify your weaknesses and your strengths, where to focus, what resources, how to manage those resources, and how to direct them. And I think Cornell does an amazing job.
So I think kind of pivoting a little bit to kind of thinking about the consumers and market adoption. Say when you're developing these new technologies in your lab, we've kind of touched how you want to think about how they might be deployed, but are you really thinking about what are you thinking about with the consumers and what the consumers might really enjoy and what they might adopt? And how are you able to balance the consumer demands with what is going to be your scientific advancement?
Yeah, there are two kind of things. One is, you improve on some of things that exist already, so you do a Me Too type, you improve the flavor and the taste and texture and consumer acceptability of a product that they are very familiar with. And then there is the other kind that there's no baseline to compare with. It's a very new and novel thing that you're giving them, a product. So I think our category is very different. It's ice cream, but it has a very little, it's a lot of unique things that consumers had no idea that can be made. So when we look at technologies, we go in this space where we can make unique and different products, where consumer acceptability becomes important, but sometimes consumers do not even know that you can make it. For example, nobody could have said that I need a microwave, or I need a light bulb. So some of these things, when you make them and present it to consumers, they say, wow, I didn't realize that it can be done in such a nice way. So we prefer in that category where, you don't just improve on something that exists, but introduce something new and novel. And you hope that, this will be a new kind of disruptive technology that consumers will enjoy. So, and then there's a lot of work to be done, which, where our industrial partners come into play. Then they can take it and figure it out, which, you know, kind of directions it should be taken to. Like, Aris was saying, should we go to a parlor setting or should we go to a coffee shop or individual ice cream machines at home? What is the business plan? And that's where industry partnership is very essential, because we are not in that domain. We don't do that sort of thing. We look at technologies and science behind it, and then we need other partners to take it to the marketplace.
Great. So, there's always going to be new researchers coming into food science, new faculty, new graduate students, new postdocs. What do you suggest they think about as they're kind of following this similar path where they're either trying to create new products and processes or improve on existing ones? What are some things that they should be keeping in mind, front of mind, when they're designing their experiments?
I mean, sometimes it leads, once you're doing research, it leads you in certain directions, which you didn't think about. But once you start experimenting and playing with it, you start seeing new directions opening up.
Mhm.
Because I had never thought that I could combine two different effects and make a very unique product. Because supercritical fluid was itself high pressure dense phase carbon dioxide was being used in many other applications, but not you know freezing and at the same time without requiring any pump or anything to mix the two streams together and create a product. So this led into a new directions basically. So this is a very useful thing to have in academic setting where you start working on something and then you start questioning and looking at different ways and then leads you to something, new and novel.
Okay, so
And that's
maybe
what
less strategy,
exciting.
more. Being
That's
open
what
to
it
new opportunities. Okay.
exactly new opportunities and exciting things that you could claim to be the first one to have done so. So graduate students get excited about it.
Oh, that's great. Aris, when you're thinking about the marketing for this, do you anticipate that there might be some consumer skepticism at all about, instant ice cream, carbonated ice cream, and then how do you plan to address that if so?
Yeah, I think the first thing in our plans is actually doing an extensive pilot program uh, into the marketplace. Um, the plan will be getting to maybe 50 to 100 shops. Because we also need feedback,
Mhm.
right? I mean, there's only so much through asking potential customers. So we need real-time feedback. One, from the design of the product, how it's being handled, what kind of improvements, and then also from the consumers, right? Because not everyone's going to taste it the way I taste it,
Yes.
right? So I think that's a good point. The other one is with some partners, and one thing that's great about this technology, it lends itself to licensing. You know, as a startup, there's only so much we can do. We only have so much dollars into utilize on it. But on the international side, we've already had discussions with groups out of Europe and out of Asia who are definitely interested. So, we need to get, our first thing is to get the product manufactured, get it tested, get the feedback, and then we'll look at some kind of what the launch looks like. So we're quite excited by it. And if I can, I'll show everyone our design that we have.
All right.
So very nice and clean and neat, uh, you know, size wise. We leave CO2 canisters I put on the outside right now just for show, but they would be internal. But it's a nice, clean device.
That's great.
Doesn't have a big footprint. And what's nice about this, the technology itself is the patentable part of the technology. We can make that with 3D printers, and we can make it anywhere in the world. The rest, the rest of the system are off-the-shelf items, and we would have strategic partners who would send in different markets. So I think we've laid out a nice little roadmap for this.
Great. All right. Well, we're coming up towards the hour. I just want to touch on a couple more things. Maybe, kind of speaking for students and for postdocs who are thinking of transitioning into either entrepreneurship or careers in industry. Kind of what are the skills that you think are most important for scientists who are looking to move into entrepreneurship from food science? What are the kind of key skills that are going to make a successful entrepreneur in the food technology space?
I mean, there are a lot of opportunities, in food science. There are many, many opportunities. Food is something that everybody eats, and it has so many parts to it, that graduate students who are in the system, they are all excited to learn about new opportunities, especially in delivering, food that are, nutritious, helpful, and meet the requirement of enjoyment and that sort of thing. So many opportunities. Not just in my lab, but in many other labs in the department. Are engaged in creating knowledge that leads to new products and new processes. And postdocs and graduate students are the backbone. They are the ones that carry out the research and get excited about it. And many of them go and start their own companies and all that. And so it's a good set of things, and we like what we see here at Cornell. That is very encouraging environment. The environment for entrepreneurship is very alive and doing well. So with all the help available throughout the system, in different ways, it it's appreciated and it's paying its dividend. You can see so many startups coming out of Cornell.
Eris, how about you? Do you think what are some of the key skills that you think you would want to see in an entrepreneur coming out of food science?
Well, I think them having an understanding of what it takes to go to the market. I think aside from the engineering standpoint, so the customer needs, how companies make money. In the end, you can have the best technology on the market, in the labs, but if you can't make it, reasonably, it's not going to find its way into mainstream. So I think getting them to understand that, and then I'll use that example, that over engineering, the class there on technology and commercialization, taking them through an analysis of a CTL technology, looking at it from prior art first, what does the landscape looks like, and then the end product, the end presentation is, do they recommend to management that it's licensed, they do a startup, or do you just abandon it? And I think, having students in any of the sciences, but, food science particularly, that's would be very helpful.
Great. Thank you so much. I'd like to open it up for any questions and answers here at the end of the presentation. So please feel free to either drop a question in the chat, or if you would like to unmute yourself and turn your camera on, you can ask a question live.
So Syed, there's one here for you, and I'll read it.
Oh, I think we've already answered this one, Aris.
Is that one?
Yeah.
Okay, great.
Yeah. I see my friend from Unilever, Leslie Herzog, is a Cornell alumni and has done so many things for Cornell. Oh, hi, Les, how are you?
Hi, Syed. Good afternoon.
Good afternoon. How are you, sir?
I am doing well. I wanted to hear about this technology and your journey along the road.
Yeah. So what's your take on it,
My take is good. I just have one question which no one has answered, and it's something that we as scientists generally don't think about, but no one has really talked about the cost of the technology, the cost of the implementation, and the cost of the final good to the consumer. So, as we know, in developing a product, you can have the best tasting product in the world, but if it doesn't meet the economic constraints, I know that was probably not the genesis or the focus of this kind of a presentation, but I also think it's an important part of the discussion. Are we talking about, and I'm just going to use some wild examples, are we talking about a scoop of ice cream that costs $1 all in? Or are we talking about a scoop of ice cream that costs $7 all in? And I'm not just talking about it in this particular presentation, but Aris, it's also something, as you talk about entrepreneurship, it's something that I don't think our entrepreneurs get a good enough understanding. If I go back to my education, and I don't even want to say what my education was at Cornell, I was a food scientist from day one. And I look back at my career at Unilever, and one of the things that I say to students when they ask, because they always ask, what do you wish you took more courses in? I always said, even though I took like 3 or 4 courses in economics and ag econ, I wish I would have taken more classes in economics, because even today, you can have the best tasting product in the world that meets all the marketing criteria, but if it doesn't meet the economic criteria, it's not going to sell.
You're spot on. I think a big part of this is, in our discussions and how we're mapping this technology out, is we have talked to the coffee shops, find out what their economics are. Can we deliver a product to them that enables them to make money and satisfy a customer need in this. And that's been the driver on this. And right now we think we can. Now, we know that the area where we need to get the cost of goods on the device down to, the plan would be actually more of a lease program, and that we would provide the ice cream mix for it. Is probably the initial model for the U.S. versus offshore would probably be a sale. So different markets have different models. Does that help?
I think it's a really good point that you've made, Leslie, that considering the economics of all of this and the launching these products is very, very easy to say we're going to just launch a new technology, but it doesn't make sense. You can't make money off of it. It's not going to be a successful business. So that's a good point to bring up.
And in a case like this, with this technology, if you lease it to 700 coffee shops at 2 o'clock in the afternoon on a Saturday afternoon in July, and the technology breaks down, what kind of support service is that shop going to have? Or is it going to have a sign that says out of order?
Oh, you're talking about like the Taylor soft serve, always breaking down.
Yep, correct. And that's why McDonald's,
Yeah.
you remember that article from about 2 years ago in the Wall Street Journal about all the breakdowns of soft serve ice cream at McDonald's.
Yeah, and that's a big part of why we need to do that pilot for 3 to 6 months into each shop, and with 50 to 100. Because we need to have sufficient feedback on what the device can do and can't do. How do we improve it? So we get the reliability on it. We don't want to be spending money on service that's unnecessary.
So in addition to having a BS and MS in food science and working at Unilever, I also owned a restaurant on the side. And my best friend is a hotelier from Cornell. So if you need to talk to someone about that side of the business, be happy to talk to either of you.
We'll be calling you. Absolutely.
Happy to do it.
Good.
That's what I love about Cornell. I mean, the network here is amazing.
Very good, Les. This is wonderful. Thank you for your willingness to help Aris and us.
Yeah,
that'll be great.
Sorry to derail the conversation, Marie.
No, I think it's great. Thank you for chiming in.
Yeah.
If anybody else has any questions, probably time for about one more.
Hey, Dr. Rizvi. Yeah,
How
good
are
to
you?
see you too. Good.
Yeah.
Yeah, it was great hearing from you again. Yeah.
Tell us something about your interest in it, in this technology.
Sure. I mean, ever since I took your food engineering class, I've been interested in the supercritical ice cream machine. And now that I'm working as a food scientist for the Army, I think it'd be a really great, like in my head, I think it'd be a really great like morale boost, maybe for like soldiers. Imagine instant ice cream on the field. How great would that be?
Yeah, I mean that would be wonderful if you can serve ice cream in a battlefield, in a theater of as part of good meal. Yeah, that will be, you can generate that instant on demand. No logistics needed except for supply of cylinder of gas, which they do use it for soda and other things anyway in the commissary. Yeah. So if there's any interest in it, let us know.
Yeah.
But what Aris, you said something, sorry.
So what's great is no refrigeration.
Yes, that too.
Yeah. Very good.
Okay.
And if there is any interest, let us know, Brian.
Yeah, we'll do. Yeah, I think it'd be great if we could catch up again.
Yeah, certainly. Good to see you, and keep doing good work, and keep the Army people happy, and ice cream will be an added benefit, Yeah. Very good.
Great.
Leslie, just
Anybody
one
else?
last thing. A big portion of this is, cost drivers are critical, especially from the investor standpoint, right? You know, can you make money, for them? Is what kind of return? And so it comes down to that, the model and executing that model. So I think we've had many discussions with different groups and, many, of course, different investors have different criteria. But it all comes back to, at the end, what is the return? Can you guys be profitable, and how long will it take before you become profitable?
Absolutely.
Well, I want to thank everybody for their time today, especially Syed and Aris. Thanks so much for participating in this Lab to Impact seminar with us. Please feel free to reach out to CTL if you have any questions or follow-up, and we're happy to make connections. So thank you, everybody.